Okay, hey guys. So I'm Rachit from Avail, and I will be basically helping you go over what Avail is and what the vision is, and how you can build on top of Avail during this hackathon. So what to expect? Uh, I'll just go through it. So the big picture around the need of a DA right now is that everything is posted right now on Ethereum, and the idea was DA was to decouple the data availability and the data storage from Ethereum and take it away. So that's what Avail is doing right now, and we already have like a testnet where you can try out Avail now. We ensure security and making sure that your data is valid through validity proofs and KZJ commitment and erasure coding. And as a company, we want to unify the whole of Web3. So that's where Avail Nexus comes into play, where we basically create a single proof that every blockchain can use and know the state transition and execution and ordering guarantees for any other chain. And all of these things, like ordering guarantees, are guaranteed by the Avail DA itself. And since Avail Nexus aims to unify all of the blockchain, we need a unified security, and that's where Avail Fusion comes into play, where you can use assets like BTC and ETH and other assets also in general to secure the Avail tech stack. So that's the Avail Trinity that I just described. And now I'm primarily going to focus on Avail DA, which is basically a data blob space where you can store all of your data, and it is easily verifiable using KZJ polynomial commitments. And we also have now Avail Nexus, as I previously mentioned. So we will basically be creating a single proof for all of the data involved across all of the blockchain, and which can be verified on another chain. So basically, you can send a payment on Optimism to someone, and that person will know on Arbitrum that yes, that transaction was done on you, as an example. And yeah. And then, as I mentioned, Avail Fusion, where we basically unify all of the security. Since we are a unification layer, that also means that all the other assets should be capable of securing the network. So, yeah, so to get into more details about Avail DA is basically where you can post your raw data. How will you able to figure out if that data is yours or not? So you don't have to fetch the whole block data or blob itself. You have a application ID assigned to your application, where you can just go to the chain, just query the data corresponding to your chain, and have your pre-image of your data. And since, as I mentioned before, we use erasure coding to secure our data, and then KZJ polynomial commitment to make sure that commit to the whole data, and which allows us to make sure that we can do a thing called data availability sampling, which is essentially just opening the commitments at multiple points and having a good probabilistic guarantee that your data is secure and in order and completed. Yes, and then. We have a vibrant ecosystem in general. You can build validiums on top of us. You can build state validating bridges. You can have shared security. And all of these are possible now with the technology that we have developed. And now there's the big overview of the architecture of Avail. Not very important, but good to have in your head. So on the left side, the original data is available to you. You erasure coded, that is you extended. What erasure coding allows you is now a particular party who wants to corrupt a particular piece of data now has to corrupt a lot of data in order to actually pass the erasure coding and the KZJ commitment checks. So this probabilistically exponentially decreases the need, the ability of someone to corrupt your data that you have posted on Avail. Now, as the diagram says, we generate a KZJ commitment against it, and then we include it in the header alongside the data and the extended data, and that's basically what an Avail block includes of. And then this data can be verified by opening the KZJ commitment at multiple points. We have a thing called a light client network. Light client network is basically responsible for doing data availability sampling on the blob which is created using the KZJ openings. And we also post a Merkle root thing called data root on the Ethereum blockchain. So your smart contract can technically verify now that a particular data was included in Avail. So all of this is available live on testnet, and you can start using it for your project. So yeah, I'm not gonna get too deep into it, but just an overview again to remind that every application will have an application ID corresponding to which your data is stored. It can be any kind of data. So as long as like it can be a roll-up data, it can be an app data, it can be a batch of transaction, it can be, but it will be you will be able to segregate it based on the application ID. And as I mentioned, like it is secured row-wise, so each row in the block of the blob is secured using KZJ commitment, which is in turn included in the header. And of the metric size also that we commit to, it is expandable and adjustable in general based on the demand. Yeah, so this is like how we work. We commit to a 256 into 256 chunk of data, and we generate commitments against it. And each cell, each block of data there can be like 256 blocks of data in turn, additionally. So if you compare it to something like 4844 from Ethereum, Ethereum can have 6 blobs of 128 KB each on an average. So it's pretty much the same size, but it's also like it can be like adjusted based on the requirements. And again, I won't get too much into details about how the consensus works, but we basically use a thing called Babe and Grandpa algorithm to make sure that to produce our blocks and make sure that the data is consistent and verify the integrity of it. And obviously, our staking mechanism is an extension of normal POS called nominated proof of stake. Again, not very important from a hackathon angle, so gonna skip it slightly. And yes, as I mentioned, we have a light client network, which is one of the main superpower of our product, I will say. And what it allows you to do is to have guarantees that the data is correct without even requiring to query a full node, because the P2P network itself is capable of also making sure that the data is correct. Yeah, so it's the same thing. Yeah, so you don't need to set trust anyone. Your light client is more than enough to do a data availability sampling against the data, and you will always have the guarantee that the correct data was included in the chain. So you can even you can easily run light client literally anywhere on a small device, even a watch or something, and you can come up with a lot of ideas where you can leverage the idea of light client and build some applications or use cases around it in the hackathon also. And yeah, so we can build a lot of type of rollups. It can be sovereigns, it can be validiums, it can be optimistic chains, it can be app-specific chains and all. So a lot of possibility open up when you have a separate DA layer. Yeah, validiums are basically ZK chains which are posting data on our DA layer. Similarly, optimistic chain which posts on data on like DA layer is like an optimum in general. And pretty sure souvenir rollups everybody is aware of, but it's basically a rollup which doesn't use a smart contract on a base layer to guarantee its security of and execution. So that's another possibility that you can make. So a rollup which posts data on a DA layer and then verifies it itself, the integrity of it, that's basically like a very high level overview of sovereign rollups. And what can we build with something like Avail? So you can build something like a custom app-specific, application-specific rollup. So you can use something like RIS0, SP1, Stacker to build an application which will basically use Avail as the DA layer. You can bring an order book exchange. You can deploy your application. You basically to be eligible for the bounties, which I'll come to again in later. You have to basically build a dApp or something which underneath uses Avail as the data availability layer for its data storage. You can build a liquid staking protocol for Avail, and you can add more features to the P2P library of Avail. And all of our tech stack is in general open source, so feel free to go through our GitHub and contribute anywhere you want. So regarding this hackathon, we have two bounties primarily. So first one is a best dApp deployed on an Avail-powered rollup. So you can find some examples, for example, an OP stack chain in our documentation. So you basically follow the steps given there, and you will be able to launch a OP dApp which uses Avail underneath. And if you build anything on top of it, you are eligible for the bounty prize. And some requirements are mentioned here, like the contracts should be deployed and verified. And you should document the contract address on the GitHub README. And the second one is you basically build a chain rollup or anything which will use Avail as the data availability layer for your product. So some example use cases can be a REST0 ZK VM, which you can use, and then submit all of the data on Avail. And you can build a liquid staking for Avail. You can build a micro rollup if anybody of you have used Stacker. That's a good use case. And yeah, you should basically be using Avail behind the scene to be eligible for the bounties. So you can, yeah, in general, like if you are using the Avail as a DA or a light client P2P network, or you are improving any of the toolings and all, you will be eligible for the bounty. This is the second one, and only 2 winners will be selected for this one. And the first one is like a general purpose where it will be a pool of submissions. Yeah, and that's primarily it. Feel free to, let's open to any questions.